Okay, so now let us talk about finding probabilities. So if we are giving a random experiment along with a sample space, so to find out the probability of an event, we basically will follow two steps. First of all, we use some specific information that we already know about this random experiment. For example, if you toss a coin, a fair coin, or throw a die, okay. And second, we will use the probability axioms, okay. So to start with, there are a few facts that based on the axioms of the probability. If you remember the axioms of the probability, which I recorded last time, is for any event, probability is greater or equal than 0. And the probability of the sample space is always equals 1. And if A1, A2, those are disjoint events, then the probability of the union, it actually equals the sum of the probability of itself, okay? So back to here, there's something which I think is very, very valuable. First off is, given event A, so the event and its complement is always equal to 1, okay. And so that's the first one. Second one is the probability of any event must greater or equal than 0 and less or equal than 1 all the time. 3, the probability of A minus B, it can be written as the probability of A minus the probability of A intersect B, okay. In fact, this part, it can have a lot of alternations, since the identity A subtract B equals A minus A intersect B, okay. And also this A minus B also equals A intersect B complement, and also this also equals A union B, and then subtract B, okay. So you can see here this, the probability of A minus B or A subtract B equals this. Also it can be equals as the probability of A union B subtract B probability of B here, okay. So, and the fourth one, the inclusive exclusive principle, probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B, okay. So those are some principles I think are very, very helpful. So now let's start to look at one example here. So example 1, seeing this. So given the info, 60% chance it will rain today, okay? 50% chance it will rain tomorrow. Okay, and also 30% chance there's no rain either day. Okay, either day. Those are the given information here, and we want to figure out the following problem. So find the first one, probability it will rain today or tomorrow. Okay, and then 2, find the probability it will rain today and tomorrow. Okay. Third one, find the probability it will rain today but not tomorrow. Okay. Last one, find the probability that either rain today or tomorrow, not both. Okay. So that's the problem. Okay. So let's take a look. Again, 6% rain today, that's chance. 50% rain tomorrow, 30% no rain either day. So those are the questions. Okay. So how do we handle this? Okay. So to solve this type of problems, I want to define the event first. Okay. So you can see the given info is rain today, rain tomorrow, and then not rain today, not rain tomorrow. And then if we define some of the event, this is how I want to define. Suppose I set A is an event, stand for it rain today, okay? And then B is the event, it rains tomorrow. Okay, tomorrow. So now the problem we have here is we can rewrite it in terms of all the probability language. That is P of A equals 0.6, right? 60% chance. Probability of B is 0.5. And as you can see that 30% chance no rain either day. How do we write that? Which is the A complement, right? No rain today, and B complement, right? So it's 30%, 0.3. So once we got this, we're starting to look at, okay, problem 1, it asks us rain today or tomorrow. So this is A union B, right? Number 2, it asks us is rain today and tomorrow, right? Number 3, probability of rain today, okay, but not tomorrow, right? But not tomorrow. Number 4, it's the rain either today or tomorrow, but not both. If we write it down, it actually have two situations, right? Either it's rain today, not tomorrow, or it's no rain today, but rain tomorrow, right? So this transformed the problem into this. So that's what we have. So for part 1, the probability of A union B, we actually can calculate it, right, based on one thing, because the part 1, what we can do is so solutions part 1, we can use the De Morgan's law, because we know A complement intersect B complement, right? And then remember that A union B complement, it is exactly A complement intersect B complement, right? So if we want to figure out the probability of A union B, which also equal to 1 minus P of A union B complement, and noticing that this complement equals here, so actually it's exactly this piece, so equals 1 minus P A complement intersect B complement, and we know that part, which is 0.3, so give us is 0.7. Okay, 0.7. So that's the first thing we can figure it out. Now, once we derive this, part 2, P A intersect B, we can solve it based on the inclusion exclusion principle, right? So P A union B equals P A plus P B minus P A intersect B. So this is 0.7 we just derived, and then P A is given, P B is given, so it's 0.7 equals 0.6 plus 0.5 minus P A intersect B, and then it turns out that their intersection equals 0.4. Okay. Number 3, the P A intersect B complement. Okay, A intersect B complement. So this gonna be one thing that we will need to know, because remember on the previous page I'm seeing that A minus B equals A minus A intersect B, parentheses, okay? Also equals A intersect B complement, right? Also equals A union B minus B here. So this is a very, very useful identities. Okay, identities. And we're looking for this, but you can see that we can rewrite it into PA minus PA intersect B, which is PA minus PA intersect B, which we know that the probability of A intersect B is here. PA is given, which is 0.6. So it turns out this is 0.6 minus 0.4 give us is 0.2. Okay. Now last part, this is rain today, no rain tomorrow. This is no rain today and rain tomorrow. So basically number 4, as long as we can figure out A complement intersect B, which as you can see here is if you alternate the order, which is P B intersect A complement, so you realize this equals PB minus P A intersect B, which is the probability of B, which is rain tomorrow, we discussed is 0.5, and then PA intersect B is 0.4, so it's 0.5 minus 0.4 equals 0.1. Hence, the number 4, either rain today, no rain tomorrow, or no rain today, rain tomorrow, is going to be sum of those two, which is 0.2 plus 0.1 give us is 0.3. Okay. So this is one small example I would like to share, and thank you. I'll see you soon.